Halo semuanya, jumpa lagi dalam Astro Wicara oleh Langit Selatan. Tamu kita kali ini adalah Profesor Ewine van Dishoeck, kimiawati sekaligus astronom dari Belanda. Ewine memulai pendidikannya di Leiden University untuk tahap sarjana sampai dengan tahap doktor. Ia mulai dari S1 di kimia dan juga matematika. Kemudian S2-nya beliau mengambil jurusan kimia dan S3 mengambil astrokimia. Saat ini Ewine adalah Profesor Astrofisika Molekul dari Leiden Observatory dan menjabat sebagai Presiden International Astronomical Union. Dan wawancara kali ini akan menggunakan bahasa Inggris. Kita langsung saja menyapa Ewine. Hi Ewine, how are you?
I'm fine, thank you. How are you?
I'm fine, thank you too. And thank you for having Langit Selatan for this interview today. And so you start as a chemist and then you became a well-known astronomer right now. Why do you like chemistry and what inspired you to have a chemistry as a career?
Yes, indeed. Certainly my career is not a traditional one and one that goes straight from A to B. I think I'm an example of a career that shows how it can go very differently from what you originally envisaged. So I started studying chemistry because I like molecules and also because I had a very good chemistry teacher at high school. So never underestimate the importance of inspiring teachers at schools. They are really the key to getting you engaged in a topic. I didn't have such good physics teachers at high school, so it was only when I got to the university and I started studying chemistry with some physics that I realized that, okay, physics is also good, and I like physics as well. But I was determined to continue in theoretical chemistry, in quantum chemistry, until, and this is one of these surprises that you sometimes can have, is that the professor in theoretical chemistry had just passed away, and it was clear that the university was not going to appoint a successor for a long time. So they said, yes, it's fine, you want to do a thesis, but there's nobody to do your thesis with. You have to look elsewhere. And then it was my then boyfriend and now husband, who was actually an astronomer and who had just taken a course on the interstellar medium. He had heard about these molecules in space. And he says, isn't that something for you? And that's how I got from chemistry into astronomy. Then basically some of the professors pointed me in the right direction. They said that, well, if you want to do astrochemistry, then you have to go to the world expert on this. At that time, Professor Dalgarno at Harvard University. So I went and studied with him for half a year. And then I came back to the Netherlands and I was able to pursue my PhD then on this boundary between chemistry and astronomy here in Leiden.
Wow, that's interesting. So, why do you choose astrochemistry, also known as molecular astrophysics, as your main research?
Yes, I think it's a very nice combination of the two topics. It combines my still love for molecules and also my knowledge, in-depth knowledge of chemistry and molecular physics, which astronomers sometimes lack. And on the other hand, the universe is such a fantastic laboratory with conditions that you don't have on Earth. So also for studying chemistry, from a basic perspective, it's very interesting because you are looking under very exotic conditions. At the same time, as an astronomer, you need to know something about molecules because it's the molecules that tell you something about the physical conditions in clouds and that tell you about the ingredients that are available for forming new planetary systems. So it's a very nice combination, a marriage of the two fields.
And yes, many astronomy students, they lack in chemistry actually. So basically, you observe the molecules in an interstellar cloud. So what molecules are you looking for?
Yes, yeah. So sometimes I say it's easier for a chemist to move into astronomer than for an astronomer to move into chemistry. That's yeah. Well, I started off as very small molecules. I started off with OH, the OH radical. I started off with carbon monoxide, of course, one of the more abundant molecules in clouds, one that we use to trace the invisible molecular hydrogen. Then water plays a very large role in my studies, especially since you need space instruments in order to observe water, at least the bulk of the water, which is, of course, the signals from space are absorbed by all the water in our own atmosphere. And so that is why especially space missions have been very powerful in studying water. But then also we're moving to more and more complex molecules.
Okay, that's and so how can we have these complex molecules like now? And why is it important to look for the complex molecule?
Yeah, so we now think that a lot of these molecules are actually formed on the surfaces of interstellar grains. So if I have say, even water, if I have an oxygen atom and I have a hydrogen atom, you cannot just simply bring them together and make a molecule. Somehow you have to get rid of the binding energy of the molecule. And you can do that in the gas by radiation, but that's very slow. But the surfaces of these tiny dust grains that are everywhere in these clouds, you see them here behind me in the Milky Way. These dust clouds, these tiny dust grains, they are a very good place for molecules, for atoms to meet and greet, so to say. Say you have carbon monoxide, which is abundant, which can at low temperatures freeze out onto such a grain. And then you can have hydrogen. There's plenty of hydrogen around, atomic hydrogen, that can then meet sort of the carbon monoxide on the grain, form formaldehyde, form methanol, and from methanol is really the starting point of many more complex molecules, simple sugars, even, maybe even as complex as glycerol, 3 carbon sugars. Also alcohols can be made in that way. So really, the surfaces of these dust grains are a very good sort of factory for making these more complex molecules.
Wow. And are we able to find the building blocks of life? Does it from the does it from the interstellar cloud, or does it form in another process? I
Yeah,
mean,
so
after the planets is formed?
Yeah, so I think it's a very good question. How far does chemical complexity go in space? Thanks to the Atacama Large Millimeter Submillimeter Array that you see here behind me, ALMA, we can now zoom in into new star forming regions and see literally thousands of lines of complex molecules. And we can try to identify them, and we see more and more complex molecules like some of the 3 carbon molecules that I talked about. Also molecules that contain the C and O bonds, like for example, formamide or other ones. And those, you could say that's the beginning of a peptide bond. So for astronomers, these are already large molecules. For chemists, they are still pretty small. And you need to grow still in complexity. But that becomes harder and harder to observe. If we look, on the other hand, at meteorites, if you look at comets, the wonderful mission to the Rosetta mission to Comet 67P, they were able to sniff the gases that came out of the comet nucleus. And there they saw, already very complex molecules present there that are probably inherited from those dusty clouds that we see there. Yeah. So then, of course, is the question: what happens? As you said, what happens then on the young Earth? So there are different theories. Having already complex molecules delivered by asteroids or by comets certainly helps kickstart the conditions for life. On the other hand, you can also, if you just have some nitrogen-bearing molecules like HCN, some cyanides, if you have water, if you have formaldehyde present, very simple molecules, then there is already a rich chemistry that can occur in liquid water, which of course you don't have in space, but which you do have on a young planet. Then you can have a whole series of chemical reactions that can also lead to the sort of RNA DNA type protein type molecules.
So that's how we hope that life can evolve, right?
Yeah, it's an interesting question. We don't know whether it will, but certainly what we can say is that the ingredients are there.
Okay. So what's the possibility of finding any form of life in like 50 or 100 years from now? Maybe on an exoplanet, because we know that we have a few, or maybe, well, as far as I know, it's not 100, but less than 50 habitable planet right now. So what's the chance?
Yeah, so that's a good question. I mean, we know that statistically every star has at least one planet, and a fraction of them are habitable. We know now already some of them to target in the solar neighborhood. I think what is really exciting is that we are sort of the first generation of humans that have the technology in order to search for signs of life. It's not going to be an easy quest. It's not just detecting water or detecting oxygen or detecting some other molecule. You need a whole combination of chemical ingredients that you need to detect, maybe some signs of vegetation or something else, the vegetation edge, that you need to detect in order to say, okay, these are a combination of biomarkers that tell us that likely there's going to be life on that planet. So it's going to be a long haul. It's not going to be simple. But the good thing is that we now have the technology in hand, and we are building the large optical telescopes on the ground and in space that can search for these signatures. So indeed, I'm not of the optimistic type that I say within 10 years we're going to find it, but I think 50 years is a good
that would be nice. A good moment. It would be nice if we have a huge progress on this. I think it will be a stepping stone. So
it will certainly be revolutionary.
Yes. And right now I want to ask more about your current positions as the president of IAU. But first of all, can you tell us what is IAU and how's the IAU work to support global astronomy?
Yeah, so the International Astronomical Union is basically the organization of all the professional astronomers worldwide, some 14,000 in total, and growing, and with more than 100 different nationalities. So it's basically the worldwide family of professional astronomers. And our mission is basically to promote and safeguard astronomy in all of its aspects. And that used to be primarily research by convening conferences, but these days it's much more than just research. It's also education, it's outreach and communication, and it is development. And we do this as the union through the international cooperation. That is sort of what we have that is different from, say, national organizations, which of course have a similar mission, but they do it on a national scale. We do it on a worldwide scale.
So as far as I know, IAU currently have 4 offices, right?
Yes, indeed. So in order to, we have a new strategic plan, which you can find on our website. And that covers 2020 to 2030. So we're just starting to implement it. That has indeed 4 offices to cover these different aspects. One, the IAU Office of Astronomy for Development in South Africa, for astronomical outreach, that's in Japan, in Tokyo. the Office of Young Astronomers, and that's hosted at the National Academy in Norway. And brand new is the Office of Astronomy Education that is in Heidelberg. Okay. And that will have its opening very soon, actually.
Yeah, as far as I know, the OAE is looking for the national contact as well.
Yes, exactly. So the strengths of all of these offices is that they have a network, say a network of national outreach coordinators and a network of astronomy educators all around the world. And that's what connects us, and that makes you be able to exchange information and build programs together.
Thank you. And I'm also interested in women in astronomy. I know we IAU, especially in 100 of IAU 100, there is a Women in Astronomy project. But now, I want to know can you give me the perspective of the number of women in IAU? And are there any statistics for distributions of women in IAU divisions, especially?
Yes. So the executive committee of the IAU has a number of working groups directly under it. So as the IAU, we have divisions, we have commissions, and we have working groups. And usually the working groups report to a commission or a division, but we have a number of working groups that we think are so important that they report directly up to the executive committee. And one of them is Women in Astronomy. So that has always been close to our heart to be able to promote that. Because we let people become an IAU member only when they have a prospect for a long-term career in astronomy, it means that we get astronomy only when members only when they are already relatively advanced in their career. So what you see is at the moment we have a disappointingly low number of female astronomers as IAU members, namely only about 18%. So, which is of course very low. Yeah. If you look at our junior members, now have a category of junior members, and then there we are more at 30 to 40%. So that's more reflective of what we see in the younger generation of astronomers, where fortunately the number of women is increasing significantly. But it's, since you're an IAU member for life, it takes a long time for these statistics to trickle through our general statistics on all the all 14,000 astronomers. So yeah, it's the gradient is in the right direction, but it's going to take some time before the overall numbers will significantly increase.
Okay, I hope that we have more and more women in astronomy in the future.
Yes, well, we try to stimulate it in various ways. One thing is to make sure that women are visible in high positions. It took the IAU 90 years before they had the first female president, Katerin Cizarski, in 2006. So that was very good. I'm now the third female president, and Deborah Elma-Green is going to be the fourth. So that's at the highest places. Also, of course, the general secretary is a very important position. So Teresa Lago. In fact, the officers are now, 3 out of 4 are female. So we stress the importance of having women in high positions, also as division presidents. Typically, somewhere between 30 and 50% of the division presidents are women. And then at all of our symposia, we always insist in having a scientific organizing committee that is well balanced in terms of both gender and geography, and also that the speakers are well balanced.
Okay. I want to know if is there any policy or plan from IAU to encourage women to pursue a career in astronomy?
Well, what we can do is encourage them. So as the IAU, we don't have any say on what happens in an individual country. Unfortunately, we cannot go to an institute and say, appoint more women. That's not what the IAU can do. What the IAU can do is set examples and stimulate young people through various programs, like making sure that they are part of the organization of symposia, that they are speakers at the symposia, at major meetings, at our invited discourses, etc. So that is one point, and then basically also collecting the statistics. We have on the IAU website under administration and membership, there is you can find all the numbers for every country, including Indonesia.
Yes.
Indonesia has, I think, 27%
Yes.
fraction of women. So you can look it up for every country, and you can make a map of that. And there's a map like that in our strategic plan. And then you can just go and talk to countries that are on the low side. India and Japan are, for example, two major astronomy countries which still have relatively low fraction of females. And then you can, start a dialogue with them and say, well, maybe there should be, more encouragement for women, or remove barriers for women in those countries to pursue a career in astronomy.
Okay, so this one is about the developing country, as Indonesia is also a developing country. What's the IAU roles and plans for astronomy in developing countries?
Well, we see astronomy actually as a very good topic to engage students in science. More than just astronomy. I mean, astronomy is, of course, a very attractive topic. It stimulates one, it inspires, it raises curiosity. So it's a very good way to attract students. And I hope that is also what is happening in your universities in Indonesia. Where these people then sort of end up in society, that's, of course, another question. Some of them, we have seen that both in developing and in developed countries, is that many astronomers, they are trained with skills in big data, they are trained in technologies, they are trained in using space data that you can also use in many other places in society. And so in that sense, it's a very good topic to study, because it provides you with many skills that you can then use elsewhere in society.
Well, maybe as an information, here in Indonesia, some students, they also interested in astronomy and archaeology, archaeoastronomy, I guess.
Yeah, absolutely. That's very nice. It tells us about our own history, the history of the universe. And astronomy and art is one of my own favorite combinations.
Wow, that's nice. So how can IAU help the country not only to promote astronomy, but also to have more astronomy in higher levels of educations?
Yeah, I think we try to help through the various programs, like organizing symposia in your regions. I think the regional meetings of the IAU have been very successful in that. It's a pity that the APRIM 2020 was not able to happen in Perth, because Perth would not have been too distant from Indonesia, and then you would be able to go to a really important and high-level meeting there. So regional meetings, of course, the ECS schools that we have, the International Schools for Young Astronomers, that train of the order of 30-40 astronomers at master student level and beginning PhD, 3 weeks of courses of high-level teachers, and also hands-on. So the International Schools of Young Astronomers have been very important in sort of helping and building a well-trained set of students that then can go on and pursue careers. So then, of course, we have the Astronomy for Development office that has regularly projects. Again, schools, say at PhD level, are important. Learning how to to work with big data sets, with archival data. I think the wonderful part of astronomy now is that we have these huge archive of data that are accessible from anywhere in the world. Now, how do we learn how to work with them? So yeah. So these are some of the ways of stimulating astronomy in developing countries.
How do you see the roles of amateur astronomer?
Oh, I think they are very important in making the connection with society, with the general public. I've seen many wonderful examples of that happening, of professional astronomers working with amateur astronomers, and then being able to reach a very large fraction of the population, the interested population there, and telling them about astronomy and getting the excitement for, especially of course when there is something happening like a solar eclipse or something like that, or a Venus transit, then you get a lot of people excited, and there I think the amateur astronomers play a very important role also in telling this story and keeping the interest.
I also curious to know about these issues. What's the IAU roles and how IAU address the sexual harassment and racism problems?
Yeah, so that is very unfortunate in society, what we see around us. Let me be clear, the IAU completely denounces any forms of racism or sexual harassment. We have a very clear code of conduct now on our website, and we encourage everybody who encounters any issues that are associated with any of the IAU activities to report that to us. So again, there's no role for any of this within astronomy worldwide. Having said that, again, the IAU does not have the power to enforce these issues in individual countries or institutes. So we can sort of lead by example and set a code of conduct. But then again, it's up to the individual institutes and countries to implement them.
Thank you so much for answering these questions. And what's the challenge to work in astronomy, especially as women, for you? And how was it when you were younger, before all the cases came to light?
Yeah, I must say that my own experience may not be representative of that of other women at that time. I was the only woman in the physics courses, so I actually saw that as an advantage because I got noticed by the professors. I mean, if you are just a little bit good at something, then they notice you much more easy because you stand out against, all of the men that were in the classes at the time. So I experienced it only as an advantage at the time to be sort of the only woman in the classes. I think the cases that you refer to, they are very unfortunate. They have happened throughout the ages. I think it's important that there are senior people that you can talk to, that you can report this to, and that can help you basically overcome these situations.
How do you see astronomy in 50 or 100 years from now?
Yeah, I mean, good question. Well, I hope that ALMA is still around in 50 years. That's because it's doing fantastic work that I'm seeing here behind me. So I hope ALMA is still there. But I mean, it will. The landscape will look differently. This quest for life on other planets, that will certainly be peaking in 50 years from now, when we really have the powerful telescopes like the extremely large telescopes on the ground, the 40-meter telescopes on the ground, maybe larger optical telescopes in space, optical infrared telescopes in space that can search for life there. All kinds of new facilities there. Astronomy is driven by new technology. So as long as we keep building bigger telescopes or more clever instruments, etc., we will find new things. So that's good. Bigger data streams, undoubtedly, if you see sort of the increase already in big data, that means that we have to learn how to work with big data, artificial intelligence, whatever data mining, that's going to be more important. Although my own experience is, also look at the data yourself. Don't let a machine decide for you. So once in a while, it's also very good to look at data yourself with your own eyes. Working together. I mean, all of these new facilities are going to be more and more expensive, and that means that not just countries, but continents have to work together in order to afford these large telescopes. So big consortia working together is certainly also going to be something of the future. But then the fact that, we have an open data policy within astronomy, and I hope we can keep that also with the other development that we're having with the transient astronomy, the time domain astronomy, so to say, which is going to be a new era. Gravitational waves, more with the physics, more multidisciplinary. That's also going to be a development. We need to be able to work with biologists, with chemists, with physicists to answer some of these questions, even with geologists.
Yes.
So these are all the developments, but we have to keep this open data policy, because if we make sure that our archives are well organized, then people from across the world, wherever you are able to access this data and to start doing science with it.
And I hope that we will have more result from the Event Horizon telescope as well.
Yeah, who knows?
Yeah. Okay, that's actually our last questions. But before we end this interview, I really hope that can you share your message to the young people who are watching this channel who want to pursue astronomy as a career?
Yes. So I usually give 3 pieces of advice to young people. The first one is make sure that you do something where you are really good in. So it's better to do one thing very well that gets you noticed than to do many things average. So that can be in terms of building an instrument or writing a program or being, having discovered something in, say, the youngest galaxies, so to say. But you need to have something that really is identified with you. So something that is really unique to you. The second thing, whatever you do it with a passion. That if you radiate some passion in what you do, that also helps your career enormously. And besides, I mean, you want to do your work that you enjoy. So make sure that you choose something that really is your passion. The third one is grab opportunities when they come along. I've had that several times in my career, and that somebody said, why don't you become a member of this committee, or why don't you go into this and this direction? And at first I said, I don't have time for this, and I'm already so busy, etc., etc. But in the end, it made the difference that, you get drawn into things that you hadn't appreciated, that get you a little bit out of your comfort zone. And then all of a sudden you say, here I can make a difference. And so grab opportunities when they come along.
Thank you so much, Irina. Thank you for your time and have a great day.
Well, thank you for this interview, and thank you for organizing this. And I hope to be able to come and meet you in person someday.
I hope so too. I wish that I can meet you maybe. I don't know. Actually, I'm thinking of General Assembly to 2021, but I don't know.
we hope,
COVID-19 problem, I don't know. Because last April, they canceled the meeting.
Yeah.
And I still don't know the progress of a CAP meeting. Will it be online meeting or I don't know.
Yeah, the CAP 20 will be online meeting, and then maybe a year later a face-to-face meeting. Yes.
I hope so. I miss all the member of the committee. I really wish to meet everyone. Thank you so much, Ewine. Thank you for.
Well, thank you.
And
all the best with your efforts. I mean, you're doing wonderful work.
Thank you so much.
Yeah.
See you. Halo semuanya, terima kasih sudah menonton program Astro Wicara, khususnya untuk ngobrol santai hari ini bersama dengan Langit Selatan. Semoga program ini bisa menginspirasi kamu tentang astronomi tentu saja. Siapa tahu kamu bakal jadi astronomi masa depan. Silahkan klik like, subscribe, dan tentunya centang notifikasinya. Terima kasih, semoga program ini bisa menginspirasi kamu semua dan memperkenalkan astronomi buat kamu. Terima kasih semuanya. Salam.